All right, so we have talked a lot about terminology, so let's just review it one more time. So there are several different ways to describe the variables of a function, and remember, a function, that is something where every domain value has exactly one range value, okay? So we're talking about functions and the different variables that are within functions. And within functions, what you have is you have independent variables. Now, there's a number of ways that we can talk about those, right? X values, domain, input, and X. Those are all independent variables, X values, in a function. But with the independent variables, there are dependent variables, which are stated as the Y values, the range, the output, but this is a new one. This is f of x, all right? And this is the same thing as y. Okay, I remember when I first saw f of x and it just really freaked me out. But then when I learned that f of x just is the same thing as y, and every time I see this f of x, in my head, I'll just think of y, and everything I know about y is true when we're talking about f of x. So when they say function notation, when they say use function notation, you use f of x. When they say write an equation, you would write the same equation with a y. So let me give you an example. So if it said write this equation, I would write y equals 3x plus 2. That is an equation. Now if they said write this same equation as a function, the only thing I do is instead of writing this y, I write an f of x. And now it is in function notation. And notice that the only thing that changed, instead of writing a y, I substituted f of x in for y because it means the same thing. So this is function notation. And this is an equation. Now the cool thing about function notation is you can really change it up. I could call it f of a, and then this x would be an a, and that would be the same thing, all right? Or, f of b. It really doesn't matter. Usually the standard is f of x, but this would be the same thing. Or you could do something like g of x. G of x is the same thing as f of x, which is the same thing as y. It's just a labeler. So these are all the different things, right? We're still in function notation. Or you could have something like g of a. The options are endless, but they're just different ways to write the same thing. All of these are in function notation, okay? And this is an equation, but really the same thing is represented here. And all of these represent the same graph. So it's the same picture. So yeah, so let's go ahead. It says an algebraic expression. Whoops, let me get this center. Sorry about that. An algebraic expression that defines a function is called a function rule. Suppose Tasha earns $5 for each hour she babysits. Then 5 times x is a function rule that models how much money she makes, or her earnings. If x is the independent variable and y is the dependent variable, then function notation for y is f of x, read as f of x. That's what this is, where f names the function when an equation in 2 variables describes a function. You can use function notation to write it. Okay, so just a review, the dependent variable is a function of the independent variable. So y is a function of x. That means y means equals. F is a function of x, or y equals f of x. They are literally the same thing. Y is equal to f of x. Okay, so let's just breathe, take it in, accept it. Know whenever you see this, this just means it's the same thing as y. So everything you know about y, as far as this being the domain, the input, the dependent variable, the range, all of these things, the y-axis. So if you have a graph, it will no longer, when you're in function notation, it will be the y, but this will represent the f of x. That's where that information, and then the x will be here. So the x-axis, you'll still call this the y-axis, but the f of x, or the y information, which is the same thing, will be represented on that y-axis. All right, let's go ahead and look at a few problems. Okay, 3A, what we're going to be doing is we're going to be writing functions, okay? So we're going to first identify the independent and the dependent variables. We're going to write an equation in function notation. So that means we're going to be using that f of x, okay, for the situation. So what do we have? A math tutor charges $35 per hour. All right, so the first thing we have to do is figure out what those independent and dependent variables are. So we have, when we're talking about somebody getting charged $35 per hour, there's a total charge or total cost, and then there's the number of hours. So I would say, what depends on the other? Well, the more hours you work, the more you get paid. So I would say that the amount that you get paid, or the amount that you get paid depends on the number of hours worked. So I'll say the amount paid depends on the hours worked. So that means that the amount paid is our dependent variable. And the hours worked would be our independent variable. So when you are getting ready to write something in function notation, you have to go ahead and define your variables, okay? And the independent is always, we're going to start with that. That is the variable. That is going to be our x. So let x represent the number of hours worked. Okay? And now we're ready to write our function notation, right? So I'm going to write f of x. That's just the same thing as y. So this is basically saying y equals $35 per hour. X is representing hours. $35 per hour just means 35 times the number of hours that you work, which is x. So there it is, 35x. That is our function notation, okay, which is just the same thing as y equals 35x, okay? Those mean the same thing, all right? Okay, let's look at our next example, 3b. So we have to write the independent, dependent variables and then write an equation in function notation for the situation again. Okay, so it says a fitness center charges a $100 initiation fee plus $40 per month. Okay, so we have to figure out the dependent and independent variables here. So what I see is it looks like there's like the total cost of all of it, right? And then there's a lot of months, so the number of months. So a fitness center charges, so the total cost of going to this fitness center, and then there's number of months. So which one, does total cost depend on the number of months, or the number of months depend on the total cost? Let's think about this. So I'm thinking that the more months that you go to this fitness center, the more that you have to pay, right? So I would say that that total cost depends on the number of months. So total cost depends on number of months. Okay? Oops. So the total cost, that ends up being our dependent variable, which means our independent variable is the number of months. Okay, before we do that function notation, we have to define our variable. Our variable is going to be the independent. So that's always the x, but you know what? I'm going to go ahead and give it a different letter just to show that that's possible. So we're talking about the number of months. This time, my independent variable, instead of being x, I'm going to have it be m. and that's going to represent the number of months. So when I write my function notation, instead of writing f of x, what I'm going to write is f of m, because m is representing my independent variable. Now this is basically the same thing as f of x, just instead of using x, I'm using an m. So what you need to know is this f of m is literally the same thing as y, okay, which represents our total cost. So then we just have to write the equation in function notation. So let's go ahead. A fitness center charges $100 initiation fee plus $40 per month. So basically, we have to pay $40 per month, which is the same thing as 40 times n, and then plus that $100 initiation fee. So that is our equation in function notation. This f of m is the same thing as y equals 40m plus 100. This would be the equation. This is function notation, which is what they're asking. They are both the same thing. It's just two different ways of writing it. And when we get later into chapter 4, we're in chapter 3 now, but when we get into chapter 4, you'll really start to understand why function notation exists. All right, so now it is your turn to check it out for 3A and 3B. So I want you to go ahead and try to find the independent variables, write an equation in function notation, okay? So for both of those examples, here's my friend the pause dragon, remind you to pause your device, go ahead and work out 3A and 3B, and when you get done, press play and we'll go over the answers together. Okay, we have Stephen buys lettuce that costs $1.69 per pound. So what I'm going to say is the cost depends on the number of pounds. So since the cost depends, that's our dependent. Number of pounds is our independent variable. Let's just go ahead. Our independent, that's what our variable. So let's say let x equal, represent the number of pounds. And then we just need to write that equation in function notation. So I'm going to use that f of x, okay, equals $1.69 per pound, which just means 169, and then you multiply that by our variable of x, which represents the number of pounds, and then you'll get the total cost. So if you have f of x equals 1.69 multiplied by x, you have the correct answer. Great job. Okay, let's go on to 3B and see how you did. So for 3B, it says an amusement park charges $6, a $6 parking fee plus $29.99 per person. Okay, so what do we have here? We have, it looks like we're having a total cost again, right? And then the thing that we don't know is the amount of people. So which thing depends on the other? What I'm going to say is the total cost depends on how many people, the number of people that go in, right? The more the people, the more the cost. So that means our total cost is our dependent variable, which means the number of people would be the independent variable. Let's go ahead and use P for number of people. We'll do it different than X, number of people. If you used X, that's fine. So for mine, I'm going to call it F of P, and then we just need to write down the relationship. So we have $29.99 per person, or $29.99 times P, and then plus a $6 parking fee. So there is our function notation for this relationship. So if you got both of them right, yokinekimashita, you did a wonderful job, and we will see you in a little bit for example 4.